In this video, we're going to look at isotopes of different atoms, as well as ways to try to determine the number of protons, neutrons, and electrons in a given isotope. A few things to take care of first. Remember that protons have a positive charge, electrons have a negative charge, and neutrons are neutral. Remember as well that protons and neutrons are heavy, and they contribute to the mass of the atom. Electrons are very light. So look at the chart above now. We have 4 different columns: isotopes, atomic numbers, mass numbers, and number of electrons. I'd actually like to add in one additional column, which is the number of neutrons, represented here by N. The first problem gives us the information of atomic number. We know an atomic number of 15. Remember that the atomic number determines which element we're talking about, and there's only one element with an atomic number of 15, or with 15 protons. That's phosphorus. Now the mass number of this particular isotope is represented by the superscript in front of the isotope, in this case 31. Look down below. Protons and neutrons are heavy, so that mass of 31 is the sum of the protons, or the atomic number, and the neutrons. For a total mass of 31, of which 15 are protons, that means there must be 16 neutrons. This particular isotope is not charged. It's neither positively or negatively charged. That tells us the number of protons and the number of electrons must balance. If there's 15 protons, there must also be 15 electrons. The second isotope is 18O, or 18 oxygen. Every oxygen has an atomic number of 8, meaning that there are 8 protons. The mass of this particular isotope is 18. Remember again that mass is determined by protons and neutrons. So if there's a total mass of 18, 8 of which are protons, there must be 10 neutrons. Look, finally, there's 8 electrons and 8 protons. Therefore, this isotope is uncharged. The next line tells us an atomic number is 19. There's only one element with an atomic number of 19, or 19 protons, and that's potassium. This particular isotope of potassium has a mass of 39, meaning that there must be 20 neutrons. Mass of 39 minus 19 protons is 20 neutrons. With 19 protons, or 19 positive charge, and only 18 electrons, or 18 negative charge, there's a surplus, or an excess, of 1 positive charge, meaning this potassium has a charge of +1. Finally, 58 Ni plus 2. This is nickel. Nickel has an atomic number of 28, telling us there are 28 protons. This isotope of nickel has a mass of 58, meaning there must be 30 neutrons. And because we know there's 28 protons and a net charge of +2, there can only be 26 electrons. 28 positive charge, 26 negative charge yields a net charge of +2. The key takeaways here: protons and neutrons are heavy, protons and electrons contribute to charge, each atom has a specific number of protons, and that's determined by the atomic number. However, you can have multiple atoms of the same element with different masses. For instance, we have here the 18O isotope, but there's also a 16O isotope and a 17O isotope. They don't differ in their protons, they differ in the number of neutrons. Thanks for watching.